This is the video for Mod 4 Lesson 6, Graphing with Asymptotes. The goal of this lesson is going to be using all the information and asymptote calculating we learned in the last section to actually draw a graph of a rational function or a sketch. So the goal is we're going to determine and graph asymptotes, and then we're also going to use X and Y intercepts to help us get a more accurate sketch of a graph. So here are the steps we're going to use, and we're going to refer to these steps throughout the examples. So we're looking at graphing with asymptotes. We're going to factor the denominator and find the domain. We're going to simplify if needed. So step 2, we're not really going to see too much in this video, probably the next video. We're going to find vertical asymptotes and horizontal and sketch them. We're going to find our y-intercept and x-intercept, and then really just draw a sketch. All right, so for this first example, it kind of looks like an example we saw in the last video. So these first 3, we already practiced calculating. The last 2 are what we practiced a lot of in semester 1 and in math 1 and 2. And then the new part is just drawing a sketch for a rational. Most of our rational functions are gonna actually all the ones we're gonna see, but there are other types out there, but are gonna be like symmetrical. So that you might see it look something where we have kind of these curved lines on both sides, or maybe they'll be in the other quadrants, but we are usually going to have some sort of symmetry across a diagonal line. Okay, so when we go ahead and calculate this out, the first thing is we check that we have the bottom factored and top factored. We do. Everything's factored. Our domain is going to be x cannot equal -3. Because we set the bottom to 0, that's the values we're not allowed to have. And then, so when we do our vertical asymptote, we know that it's going to be -3. Our horizontal asymptote, well, we got a degree of 0 on the top, a degree of 1 on the bottom, so the bottom is going to get bigger much faster than the top because the top is going to stay at 6. So the bottom is bigger. So this would be y is equal to 0. So if I go ahead and sketch this before I draw the rest of it, I'm going to have a horizontal asymptote at y equals 0, a vertical asymptote at -3, and so our graph is going to kind of go around these 2 asymptote lines. We're now going to go ahead and find our y and x intercept to kind of figure out what pieces, we just broke our graph into 4 pieces, what pieces it's going to fall in. So our x intercept, remember our x intercept, you're letting your y value be 0. So I'm going to go to my function, and I'm basically putting in 0 in for my y value. And really what that's the same as, it ends up being the same as setting the top equal to 0, right? Because you know, when you clear the fraction like we already talked about, and you don't have to do this every time, but a much faster way is just setting the bottom equal to 0. So I get something like 0 equals 6, which doesn't make sense. So what that means is I actually don't have an x-intercept, because we got something that didn't make sense. I can't have 0 equals 6. But for the x-intercept, you would just set the top to 0, because the bottom would end up getting zeroed out. And then, so we don't have an x-intercept. For the y-intercept, we're just going to go ahead and do the same thing and put 0 in for x. And then when we go ahead and put that in, we would get 6 over 0 plus 3, which is 2. So our y-intercept is 0, 2. So I'm going to put a point at 0, 2. And so now I'm just going to do my best. There we go. I'm going to do my best just to draw a sketch. So we're going to go ahead and draw a sketch here. I know it's in this this section of the graph, and then I know the other piece is going to be really kind of the vertical, we call it like vertical angles almost, but in the diagonal of that. So you kind of get that nice symmetry. You're just doing your best to do a sketch. If you want to be specific, you might see I'm 1, 2, 3 over and 2 up, and then do the same thing on this side and reflect it. But again, you're just drawing a sketch, and then that would be our final answer. In our last example, we're going to kind of do the same thing. And where we can factor first if we like. We don't have to for this one because nothing would cancel, but if we needed to, you could see the top does have a GCF, and I maybe would pull out a 2. But this one, nothing canceled or anything like that. And we would just do our calculations now. So our domain is x cannot equal 4 because that's our bottom. Our vertical asymptote then would be x equals 4. Our horizontal asymptote, you can see that there's an x on the top and bottom, so this would be like a 1-to-1. And so when we simplify, negative 2x over x is negative 2. So our horizontal asymptote is negative 2 because it's 1-to-1. We can go ahead and sketch that first if we like. So we have 1, 2, 3, 4 for our vertical. And then our horizontal actually has one at negative 2, so that's down here. And then our x and y intercept, again, our x intercept is where our y value is 0. So if I go ahead and look at my function, it's actually the same as just setting the top equal to 0, right? Because that bottom 0 is out. So if I go ahead and do that, we're going to get a positive 6. So we have an x-intercept of 6, which would be 1, 2, 3, 4, 5, 6. So right here. Okay, and then for the y-intercept, we're going to let our x value be 0. And so you can do either the factored one. It's sometimes faster to do the original one because when you put 0 in, it's really the same as having 12 over negative 4 because you're putting in 0. There we go. It's the same as when you put in your 0, it's the same as 12 over negative 4 because all the x stuff goes away, kind of like we saw with polynomials, and we get negative 3. And then now we're just going to go ahead and do our best to try to sketch the graph. So I know one piece is in here. I'm just going to draw a sketch. If I want to be fancy, I can maybe make it symmetrical. And then I know my other piece will be down here. And then that would be it. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.